Hello scholars, this is the Module 1 Mid-Module Test Review Tour. Please have a paper copy of the test review tour and a pencil ready to take notes about problem-solving steps as well as correct answers. Question 1. Jose and Tanya's parents decide to pay them an allowance each week for doing their chores around the house. Jose is older than Tanya and has more chores to do. In their first year, Jose will be paid $15 per week and Tanya will be paid $10 per week. Their parents told them that after every year, they will each be given a raise of $3 per week. Part A. Fill in the missing values of the table. So we can see that from years 1 to 2, Jose's allowance goes from 15 to 18. What will be Tanya's allowance in year 2? Tanya's allowance will increase by $3 also, giving her an allowance of $13. And that pattern is going to continue. So in year 3, Jose will have an allowance of $21 per week. And Tanya $16 per week. Part B. Is the relationship between Jose's allowance and Tanya's allowance proportional? Explain your reasoning using the table. So, what do we do to determine if a relationship in a table is proportional? First of all, we need to focus on the numbers we're comparing. So, first of all, we need to ignore the years column of this table. We're comparing Jose's allowance to Tanya's allowance. So what do we do to determine if Jose's allowance is proportional to Tanya's allowance? So, we're searching the table for a constant k, such that every value of x times k equals y. So how do we figure out if there is a constant k in the table? So to determine if there is a constant k, we divide. K is equal to y divided by x. So I can substitute my x, y pairs for each row. 10 to 15. 13 to 18, and 16 to 21. We need to determine if these ratios are equivalent or if they're not equivalent. The way to do that would be to divide. So I can divide 10 by 15 and then compare that to 13 divided by 18. So after having divided 10 by 15, I realize that's equivalent to 66/100, or 2/3. So now you need to decide if 13/18 is equivalent or not equivalent to that. And so 18 will divide into 13 0 times, and then into 137 times. And really, that's enough information for me. I don't have to continue my division, because I can see that these two ratios are not equivalent. So the fact that the answers to the division problem in the first row is different answer to the division problem in the second row tells us that no, the relationship is not proportional. When I divide, the answer is different for each row. There is no constant. So with no constant, there's no proportional relationship. Question 2. As part of their job working in a clothing store, Bruce and Sylvia fold shirts on the display shelves. For every 3 shirts Bruce folds, Sylvia folds 5 shirts. Is the number of shirts folded by Bruce proportional to the number of shirts folded by Sylvia? Explain your reasoning using a graph on the coordinate plane. So we can accomplish this task in some organized steps. 1, we need to determine the variables and organize data in a table. So I have a table set up x, y. So we need to assign our two variables, the shirts folded by Bruce and the shirts folded by Sylvia, in their positions x, y. And this is a case in which we can just use the order in which they appear. We could, since Bruce appears first, we could put Bruce in the X position and then Sylvia in the Y position. So what would it matter if we chose a different order? Would it change the relationship if we put them in positions in different order? So, no, it would not matter if you had chosen a different order for the variables. So you don't have to worry that if you chose Sylvia for X and Bruce for Y, that you would get a wrong answer. And you also don't have to do this both ways. I'm just trying to show you that no matter which order we assign the variables, we should still be able to determine if the relationship is proportional. So what is the first ordered pair we can organize in our table? What's the first ordered pair of x, y for Bruce, Sylvia? The first ordered pair was 3 shirts for Bruce, 5 shirts for Sylvia. And then this pattern would continue when Bruce has folded 6 shirts, Sylvia has folded 10. And when Bruce has folded 9 shirts, Sylvia has folded 15. And so this pattern could continue. Maybe we could do one more. We could say then when Bruce has folded 12 shirts, Sylvia has folded 20. This pattern could go on, but we're simply trying to collect some data that we can plot on a coordinate grid and look at its shape. So we have enough data to do that. So when we have data organized in the table, step 2 is to plot the data on the coordinate plane. So here's what our data looks like. Bruce 3, Sylvia 5. Bruce 6, Sylvia 10. Bruce 9, Sylvia 15. And then Bruce 12, Sylvia 20. After plotting our data on the coordinate plane, it's time for step 3. Test. Do the points align to the edge of my ruler? And if yes, connect the points and extend the pattern in both directions to the edges of the coordinate plane. So go ahead and put your ruler on the points, and do all the points align to your ruler's edge? So our answer should have been yes. When we put the edge of our ruler, the points, all of the points align to the edge of our ruler. And so we connect the points and extend our line in both directions to the edge of the coordinate plane. So what does our graph tell us? Is the relationship between shirts folded by Bruce, the relationship in the shirts folded by Sylvia, proportional? Yes or no? The answer is yes for 2 important reasons. Yes, it is proportional because the graph is a straight line that intersects the origin. So for those 2 reasons, a straight line that intersects the origin, the relationship is proportional. Question 3. When a meal is sold in a restaurant, the the restaurant takes the cost of the meal and the customer gives a fraction of the cost of the meal to the waiter as tip. The graph below shows how much money a waiter or waitress makes in tips given the total amount of money brought in by the restaurant from sales of meals. What can we tell about the relationship between tips paid to the waiter and sales of meals by restaurant just by looking at the graph? So by looking at the graph, we know. What's something we know just by looking at the shape of the graph? So by looking at the graph, we know tips are proportional to sales because it is a straight line intersecting the origin. Now when we look at part A, identify the constant of proportionality between tips earned by the waiter and dollars brought in by sales of meals. We know there must be a constant proportionality because we can see the relationship is proportional. And we also know that the constant of proportionality, k, is equal to y divided by x. Really, I need one pair of x, y values to calculate k. I'm going to use the first pair of x, y values that appear. So we see that 30 is in the y position, so I'd have 30 divided by 200, the value in the x position. So 30 divided by 200 will translate to this division problem. So if we're going to divide 200 into 30, and then we should think about why that answer we get makes sense. But what I just recognized is I was about to solve a harder math problem than I need to. So what I saw is that 30 and 200 share a common factor of 10. So if I divide 30 by 10, I could have 3. And if I divide 200 by 10, I could have 3/20ths. And so that would be a far simpler number to use as opposed to 30 and 200. So at this point, I could stop. I could stop and express my constant of proportionality k as 3/20ths. And then when we look forward to B, write an equation relating tips earned by waiter y, well this is y's place, to dollars brought in by sales of meals x, well this is x place. And so we could say that the tips earned by the waiter is equal to 3/20ths of the meals sold by the restaurant. And so the waiter earns a fraction of the sales of meals by the restaurant. If I wish to express my constant of proportionality as a decimal, this is the division problem I could solve. 20 divided into 3. Here, if I divide 20 into 3, I get 0 and 15/100ths. And so I could write an equation, and my answer could also be my constant in decimal form. So I could say that y is equal to 15/100ths times x. Both of these equations are correct. 3/20ths is equivalent to 15/100ths. Just need to decide, we think it's better to use the fraction form for the constant or the decimal form. Both would be counted correct. According to the Part C, according to the proportional relationship, how much money did the restaurant bring in from sales of meals for the week if the waiter earned $600 in tips that week? To help make sense of this problem, we're going to refer back to the graph. It says, if the waiter earns 600 tips $600 in tips that week. We find tips on the y-axis. So we're imagining if there was a 600 on the y-axis, this graph kept going past the data that we can see. We have y equal to 600. What would be on the x-axis? How much sales was brought in by the restaurant? So we're thinking when y is 600, what is x? So remember the equations we created in part B. When we said y is equal to 3/20 times x. Or equivalently, y is equal to 1/1500 times x. So we'll show both versions. We don't have to do both. You can decide which version of the equation you find most useful. We need to ask, where does our number 600 go? Does it go in the position of x or in the position of y? We find tips. 600 is the amount of tips, and we find that on the y-axis, so it goes in the y position. So we have 600 is equal to 3/20 times x. 600 is equal to 1/1500 times x. So how will we find out the value of x, or the sales of meals by the restaurant? What operation are we going to perform with these numbers? 3/20 and 600, 1/1500 and 600. In our practice, we've defined x as equal to y divided by k. So we're going to divide 600 by 3/20, or 600 divided by 1/1500. Here's the setup of our problem. 600 divided by 3/20, and equivalently 600 divided by 1/1500. Here on the left, I'm going to solve the equivalent multiplication problem by multiplying 600 over 1 times the reciprocal. As I was saying, the reciprocal, which I forgot to flip over 3/20. So 600 over 1 times 20/3. And then also, I'm dividing by a decimal here. So I need to move my decimal in 2 places to the right. If I do that in my divisor, do that in my dividend, 2 places to the right to divide 15 into 60,000. So when we carry out this multiplication here on the left, we end up with 12,000 divided by 3, which is equal to 4,000. So x equals 4,000. When we do our division, 15 into 60,000, 4,000. So x equals 4,000. So no matter which form of the equation we choose, the fraction or the decimal, lead us to the answer: the restaurant brought in $4,000 in sales. Question 3D. Describe what the point 0, 0 on the graph represents in terms of the situation being described by the graph. So again, we'll use the graph to help make sense of this problem. When we have any point x, y on a graph, it represents sales. X represents sales and y represents tips. And so if we have the point 0, 0, or the origin, then that is a sentence. Remember, each point on a graph is a sentence written in algebra describing this relationship. We're going to translate this sentence to a complete sentence in English. So here is that sentence in algebra translated to English. The point 0, 0 represents that when sales of meals, there's our x variable, brings in $0. The waiter earns $0 in tips, and there's our y variable. So both of those variables appear in our statement. Our final question, 3E. Which point on the graph represents the amount of money the waiter gets as tip for $1 of money brought in from sales of meals by the restaurant. To help make sense of this, we can use a table and a graph. We're going to use the table and the graph to help us figure out this point that represents the tips the waiter gets for $1 money brought in from sales. So sales are on the x-axis. So if we have a 1 on our x-axis, that would mean we have a 1 for x in our table. And then we know that in any proportional relationship, when x is 1, y is k. We know k to be either 3/20ths or 1500ths. It's equivalent decimal. So what we have here is y equals k, or 3/20ths. Okay, that's always true. When x is 1, y is k. And in our earlier work, we found out what k is. And so now, that coordinate pair would be when x is 1, y is k, or 3/20ths. An equally as good answer, if you want to express it as a decimal, be 1500ths. Either of these are correct. So, since this is in the context of money, we could use the decimal form. The point 1/15 cents or 1/1500ths represents the money the waiter gets as tip for every $1 in sales. So you may have been out to eat and maybe parents leave a tip. And so a 15% tip is what's expected. So for every $1 in sales or $1 in cost of the meal, we're expected to give the waiter 15 cents as tip.